All right, let's talk about cis-trans isomers. These are isomers that have a C double bond C in them somewhere. And if you have a C that's making a double bond, it's also going to be making two single bonds. Vesper tells me that they're going to be 120 degrees apart, and I should draw it like this. Please do not draw them 90 degrees from each other like here. Draw them 120. That's the proper way to do it. So what's the big deal about these? Well, anytime I have a single bond, and we were using the model kits, they rotate these bonds. But this guy, the double bond, does not rotate. So when I take a look at these two molecules, C double bond C with four things bonded on, I don't care what they are, A, B, ED, these guys are locked in place. A is always on the same side as E, B is always on the same side as D. But if I was to switch the positions of A and B, so now it's BA here, B is across from E and A is across from D, these guys are different. They would have different physical properties, possibly different chemical properties, and therefore we need to name them differently. So let's take a look at a couple of examples. Here we have four carbon chain. We're going to be looking at a bute. It's got a double bond off of number 2. So this is 2-butene, but there's two types of 2-butene. I can have this guy, or I could have 1, 2, 3. I could have this carbon down here. And both of them would be 2-butenes, but they are completely different. This guy has the this guy has these two things on the same side of the double bond. Same side of the double bond. Boom. They're up here. Yes? Not one up and one down like I had drawn a moment ago. So this guy would be called, they are on the same side, and when they're on the same side, we use the word cis. So this would be cis 2 butene. Now this example over here, now in this case, let me get this guy out. If this is our, wait, let me do this. If this is our like midline right through the middle here, we can see that the big group on this side is the methyl group, not a hydrogen. And the big group over here, I have a hydrogen and I have an ethyl group, and the bigger one is down here. In this case, the two big groups are on opposite sides of this dividing line down the middle. So this one is a trans. This is trans. And the double bond is off of number 2. Oops. Again. Who knows why that's happening? Trans to pentene. Let's look at the next guy. I'm going to draw that dividing line down the middle again. And the big group over here, I have an H on this side and an H, and over here I have a methyl and a methyl. Now, the question you have to ask yourself is, if I was to switch these two things, would I be getting the same molecule? And the answer is yes. If I switch H with H, I get this again. If I switch methyl with methyl, I get this again. So this is, there's no cis-trans here. No cis. No cis-trans here. This is 3 carbons in a row. Methyl group off of the middle guy. So this is 2 methyl. Yes. The double bond is off of number 1, so it's 1-propene. Another example now, if we're asked to actually draw this thing, my advice is always the same. Put the double bond right in front of you. So I'm going to put a C double bond C. It's right in front of me. I see trans. That means I'm going to need a big thing up, and a big thing on this carbon will be going down. Where is the double bond? It's off of number 3, so that means that I need 2 more carbons up here. Yes? And it's trans and it's octene. I've already drawn 4. I'm going to draw 4 more. Yes. 1, 2, 3, 4, 5, 6, 7, 8. Double bond off of number 3. It's trans. I haven't drawn in the 3-methyl yet, so it's down like this. Yes. And then there will just be an H here. If I put this dashed line through the middle, right? If I look at this carbon on this side, the big group is up. 2 carbons is bigger than 1 carbon. Over here I have an H, and then I've got 4 carbons in a row. This is the big group. Yes. So it looks like the molecule that I've drawn here, even though I've drawn all over it, is 3-methyl trans 3-octene. Just one other example with double bonds. This looks different than a different ending than I've ever seen before. Dec means 10, yes. Di usually means 2. Ene means I got a double bond. So this, when I see the ending at diene, that means that I've got 2 double bonds. And where are these 2 double bonds? They're off of carbons 2 and 5. So C2, 3, 4, 5, 6, 7, 8, 9, 10. I need double bonds off of number 2, 3, 4, 5. That's this, and then the rest are going to be single bonds that I can draw in, and then I can put in the appropriate number of H's all over the place. But this is the ending I use when I need 2 double bonds. And if you see this ending at triene, that means I need 3 double bonds. Why is the A here? It's there to just make it sound better. If there's no A here, it would be dec-diene. Decadiene just sounds, it flows a bit better. And so that's our video on cis-trans isomers. Please draw them at 120 degrees. And cis is when the big group on each carbon pointing on the same side. Trans when the big group is one up and